We're surrounded by these environmental stressors that affect our health, our decisions every single day. Things like air pollution, temperature extremes, they're chronic, they're insidious. But here's the really bizarre thing. We mostly just ignore them.
We do. And we ignore them because, these threats exist just outside the range of our normal senses. They're abstract. They're just numbers and graphs, so the danger never feels,
Right, that cognitive distance, that's the failure point. We have mountains of data now, right? From government monitors to all those DIY air quality sensors across Europe, India. But the data alone doesn't seem to be enough.
It isn't. It's what we call information overload. It just doesn't create a sense of urgency. You can have all the maps, all the real-time numbers, but if your brain doesn't feel the threat, viscerally, you just rationalize it away. We need a cognitive shortcut.
And that shortcut is our mission for this deep dive. We are looking at a really remarkable technological breakthrough called the sensory bridge. We're going to explore how augmented reality, or AR, is being used to turn all that abstract data into a tangible, visible reality. And it's forcing a huge shift in how we perceive environmental risk. Okay, so let's unpack this idea. Think about it like this. Imagine you have to clean a massive, incredibly messy room. It's full of hazards, but you have to do the entire thing with your eyes closed. And your only guide is someone occasionally shouting, confusing coordinates at you.
That is a perfect analogy. That's basically how we're tackling hyperlocal pollution right now, blindly. And in environmental psychology, that whole systemic failure has a name. We call it the tragedy of cognition.
The tragedy of cognition, that sounds appropriately dramatic, but it really nails the problem, doesn't it? Why do we fail to act, even when the data on something like long-term climate change is just overwhelming?
It's because our brains are systematically biased toward what's right in front of us. The main culprit here is a phenomenon known as temporal discounting.
Temporal discounting. Okay, let's ground that term a bit. It sounds like a deal on time, but it's really a failure of foresight, isn't it?
Exactly. Our brains are hardwired to prioritize immediate rewards and immediate punishments. It means that some outcome way off in the future, like damage from chronic pollution decades from now, it just holds less subjective weight than what's happening right now. If the air looks clear today and I can't feel the particulate matter in my lungs, well, I'm not motivated to make a big change.
So that slow motion crisis just gets filtered out. It's not seen as urgent.
Exactly.
And I've seen scientists try to solve this with really sophisticated data visuals. I remember one of the source materials mentioned this complex 3D map of nitrogen dioxide, the NO2 distribution over London. It was incredibly detailed, but what was the actual outcome?
The outcome was a classic data dump. The complexity actually backfired. Studies show that even when data platforms are accessible, community groups really struggle to apply that kind of raw, non-customized data to local policy. It was too much information without any immediate actionable context.
So if the data is too generalized or too abstract or just too much, the brain just sort of switches off? But the problem isn't just the volume, it's the granularity we're missing, isn't it? I mean, pollution isn't uniform across a city block.
That's the critical infrastructure gap. You can't just rely on that one fixed monitoring site 10 blocks away. You need hyperlocal data. You need to identify the real minute-by-minute hotspots.
So we need to know the air quality, not just for the city, but for, like, the corner of Main and Elm at 4:30 in the afternoon.
Precisely. For that, traditional monitoring is, it's woefully insufficient. What you need is comprehensive mobile monitoring. So specialized equipment on vehicles driving specific roads. That's how you capture the variation at scales as fine as, say, 30 to 150 meters. It reveals the invisible plumes that fixed stations miss completely.
And this brings the problem right back to you, the listener. You might read a graph showing rising levels of particulate matter, PM 2.5, which is linked to, devastating health outcomes, cancer, heart disease. You get the risk intellectually. But because you can't see those tiny solids floating in the air, the risk stays abstract. Your body is dealing with a stressor you don't even know is there.
And that failure to register the threat immediately, that's what this technology is designed to fix. We're closing that cognitive distance.
Building the sensory bridge. Okay, this is the exciting part. The new method. Visual engagement through augmented reality.
Yes. AR is the tool that can overcome that psychological distance. So instead of looking at a map on your phone showing what the air quality was 10 minutes ago, AR allows for a dynamic visual overlay of that data in real time, right onto the physical world as you're looking at it.
This is where it gets really interesting. I know there have been, simpler apps in the past. They tried visualizing pollutants as like floating balls or something. It felt a bit gimmicky, but this new concept from projects like H2020 Compare, they're aiming much higher. What's the big scientific challenge they're solving?
The challenge is moving beyond simple 2D overlays. It's about developing innovative visualization techniques for massive amounts of spatial data in a 3D AR space. You're merging two worlds, the physical world and the real-time sensor data, into one coherent, meaningful experience.
How do they actually do that? That sounds incredibly complex. We hear terms like Unity and AR Foundation thrown around. What do those actually do?
Well, think of Unity as the 3D game engine. It builds the foundation, the virtual streetscape. And AR Foundation is the tool set that helps that virtual image stick perfectly onto your real-world view so it stays geolocated as you move around. We use them to transpose the GPS data from those mobile sensors directly into the virtual world's coordinate system.
So the system knows exactly where a sensor picked up a pollution spike, and then Unity and AR Foundation make that spike appear in the exact same spot on the street you're looking at.
Precisely. This is not some graph just floating in space. It is a scientifically accurate 3D representation of a hazard plume right there in front of you.
Wow. So this is literally like putting on X-ray glasses. You're no longer reading columns of numbers for nitrogen dioxide. You're actually visually experiencing that data as a graphical object overlaid on the street. So if I'm standing at a busy intersection, what does the pollution actually look like? Is it a big red bubble?
Oh, it's much more nuanced than that. The data might be shown as a pulsing, translucent cloud, maybe a plume of colored smoke, let's say red or orange for high concentrations of NO2. If it's extreme heat, it might look like a visible shimmer in the air over the asphalt. The key is that the visual communicates density and movement and intensity, just like seeing real smoke. And this is so important for understanding threats we previously couldn't grasp, like ultrafine particles, UFP.
UFP, those are even smaller than PM 2.5, correct?
Much smaller. And they may be far more toxic because their size allows them to penetrate deeper into the lungs, maybe even into the bloodstream. But UFP is less studied because its concentration is so variable. So making that invisible risk visible, maybe as a dense swirling fog near the ground, that is the key function of the sensory bridge. It changes the threat from abstract data to immediate personal vulnerability.
I can totally see how visualizing that specific threat would create instant feedback, but the whole point of this field, environmental psychology, is to encourage pro-environmental behavior. So a skeptic might say, this is just a fancy video game. What's the proof this actually changes how people behave?
That's the core question. And the research shows it fundamentally shifts our psychological perception and our physiological representation of the environment. You're moving the threat from an intellectual concept to an embodied reality.
Okay, embodied reality. How do scientists prove that's happening? How do you measure a shift in perception?
They use immersive virtual environments, so highly controlled digital landscapes. And there, they monitor subjects' physiological responses. They focused on tracking something called somatosensory comfort.
Somatosensory comfort, that sounds like a very scientific way of saying how comfortable your body feels.
It is, but measured objectively. They tracked it using metrics like skin conductance, or SC. Skin conductance measures how much you sweat, basically. Yeah. It's a reliable, unconscious indicator of your emotional arousal. When you're stressed or fearful, your SC spikes. It's an immediate bodily stress metric.
So they're measuring how stressed a person feels in a digital world based on their body's reaction, not what they say they feel.
Precisely. And they found a huge correlation. In a digitally simulated ecological area like an ancient forest, subjects had lower SC, lower emotional arousal, and higher comfort. But in digitally simulated sun-exposed areas, their SC spiked. The key takeaway is that the purely visual information registered physiologically. It immediately altered their baseline stress response.
So the data literally hits different when it's visual and immersive. It bypasses the rational part of the brain and goes straight to our immediate emotional centers.
That is the pathway to changing behavior. Fear, for example, is associated with assessing a situation as uncertain, uncontrollable. That uncertainty fuels anxiety, which usually leads to avoiding the risk. But by making the risk visible and tangible with AR, we replace that uncertainty with immediate controllable feedback.
Wait, but wouldn't seeing a plume of toxic air just create more anxiety?
It could, but that kind of visible clarity drives a different action than abstract anxiety. Abstract anxiety leads to denial. A visible, immediate risk leads to a specific, proactive response. I'll walk across the street, or I'll put on a mask, or I'll take a different route tomorrow. You're encouraged to respond, not just avoid.
I see. So it's the difference between, say, reading a graph about a potential fire somewhere in the city and actually seeing the smoke pouring down your block. The intellectual knowledge gets replaced by that immediate sensory jolt you need to act.
And that jolt is what lets us overcome that deep-seated tragedy of cognition. We're taking a climate stressor, like a heat wave, which we know is linked to things like aggression and irritability, and we're making the feeling of that stressor visible.
The sensory bridge, then. It's really a mechanism for turning abstract understanding into an embodied, immediate reality. It's about democratizing data, not just by making it available, but by making it undeniable.
And the policy implications are enormous. By giving citizens this kind of actionable visual proof of hotspots, you empower them. You empower them to drive specific changes, whether that's informing land use zoning or requiring air filtration in certain buildings or fighting for safer school locations.
This technology really does hold the promise of guiding environmental governance away from, these empty slogans toward targeted behavior-based interventions, all by leveraging what truly influences us, our senses.
It's the ultimate tool for making the most critical threats to our health impossible to ignore. Because if we can see the poison, we have no excuse not to clean it up.
The next time you're outside, just think for a second about the invisible threats that are all around you, the pollution, the thermal stress. Now imagine what you would do differently if you could actually see them, right here, right now. That innovative insight into transforming abstract environmental data into actionable visual reality comes from Varia1. If you are interested in exploring how advanced visualization and data synthesis can accelerate environmental intelligence and drive targeted behavioral change in your community, you can find more information by visiting the Varia1 website today.